Alrighty dighty Math 7, how you guys doing? Hope everyone is fine and dandy. Today we are going over 13.6 and we are talking about slope. Now, slope is something that you'll notice that I've got graphing paper. Not all of our notes today are on graphing paper. It will help you if you can. While we talk about this, slope is a way to define our function. Slope, now slope is a ratio or a fraction where we describe how the function rises over how it runs. Now, all this might seem like gibberish right now. It'll make sense in just a moment. Another way to describe it is our change in y over our change in x. Again, what we're doing is we are describing functions. Describing our function. Okay. The change in y over the change of x. Now, we always see this variable for slope as the letter m. Not exactly sure why. That's just the way it is. Okay. So what we're going to do is we're going to find the slope of the line shown. Okay. So let's say I've got this line here. Okay, and I'm just covering up a little bit of work over here, but right, this is my y-axis, this is my x-axis down here. I go from -1, 0, 1, 2, 3, 4, 5, and I have these two different points. Point 1 is at -2, -1. Okay, so again, for point 1, I'm going on my x-axis, I'm going to go over to -2, and then I'm going to go down to -1. So this is where point 1 exists. Point 2, I come over to, let's see, again, this is my x-axis. I come over to +3, so this is 1, 2, and 3. Ding, ding, ding. And then I come up to 5. Ding, 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 ding. This is my second point. Now, again, for the slope, we describe it by the change in y, that's the rise, over the change in x, that's our run. So, between points 1 and 2, how much does it change along the y-axis? How much does it change vertically? Well, let's see. Point 2 is all the way up here. Point 1, so my change is 1, 2, 3, 4, 5, 6, and I'm moving up. So my vertical change is +6. My rise is 6. Now, my horizontal change from point 1 to point 2 is 1. Again, I'm starting here, which is at -2. 1, 2, 3, 4, 5. Now, you might wonder, why did I move my pencil all the way up here? Well, because this whole line right here is -2. It happens to be at both -2, -1, right? That's where the x-axis and y-axis intersect. But I'm counting from here over here, right? If it works better for you, you could use your pencil. So I'm starting at -2, and I'm moving over 1, 2, 3, 4, 5. Now I'm keeping my pencil vertical while I do this. So 1, 2, 3, 4, and I move over 5, or I run 5. So my slope in this case is 6/5. slope of, this will say function. Slope of function is 6/5. Now, there is a second way to show this. So you'll notice that I have here what's shown as delta or triangle y, but it's a Greek letter, which is delta y over delta x. In this case, delta means change. So the change in y over the change in x. And what you can do is you can subtract these to find the change. I'll have this formula shown a little later, but let me just show you now. So what I'm going to do is I'm going to subtract y1 minus y2. So my y1 is -1 minus 5, or 5 minus -1, right? So I'm subtracting this minus that. 5 minus -1 is +6. And then 3 minus -2 is going to be +5. So mathematically, we could figure out with subtraction. I'll show this method in just a moment. So we could either figure it out with subtraction, or we could figure it out by following the graph. Okay, but again, our slope is at 6/5, and because it's +6 over +5, we call this a positive slope. Now, here's an example of a negative slope. So let's say I have okay, so here's all my information. So point 1 is at -1. Forgive this line, I don't know what that's doing there. So again, I've got my y and x axes. This first point, point 1, is at -1 comma +2, and the second point is at +1 comma -1, right? So here are my 2 points. Now again, what's my rise? So I'm going from here, and I'm going down 1, 2, 3. So I'm actually going down along the y-axis, giving me a rise of -3, and then a run again of, since I'm moving in the positive direction on the x-axis, of 1, 2. So my slope is going to be -3/2, right? This is a negative fraction, negative slope. Again, if we're going to solve this the mathematical way, change in y over change in x, let's say I do 2 minus -1. 2 minus -1 is going to be +3. But then, since this is my first point, -1 minus 1 over -2, giving us the same slope. Okay. Again, in just a moment, I'll show this second format of subtraction. But first, let's talk about some slope characteristics. How do we know if it's positive or negative besides just looking at the ratio here? If it's positive, our line will always go up and to the right. Or, depending on your perspective, it's going to go down and to the left. So let's look at this first one. We know this is a positive slope. And as we are going to the right, our line is going up. Up and 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 up. this is a positive slope. Whereas this second one, this negative lines go down and to the right or up and to the left. Again, that's this guy. And as I'm going to the right, my line is going down. So this is a negative slope. In fact, anything that looks like this is negative, whereas anything that looks like this is positive. Okay. There is another type of line that we could have. That's called a horizontal slope. That's when there's no change in y, and our slope equals 0. Yes, you will need to know this on homework, quizzes, and tests. This will be important. The other thing to note is that vertical lines is there's no change in x, which means that we have an undefined slope. And that's because if there's no change in x, our x stays the same, while our x is then mathematically 0. You can't divide anything by 0. It just doesn't work. Also, vertical lines are not functions. We don't need to worry about this quite yet. It's just important for you to know. I want to give you a couple more examples of positive and, that's the cruddy one, of positive and negative slopes. So this one here, let's see, remember I've got my y and my x. This one, because it goes up and to the right, up and to the right, whoa, up and to the right, it's positive. Whereas, let me grab a different color. Whereas this one here, let me draw something like this over to here. So it's not very steep and dramatic. However, it's going down as it goes to the right. It's down and to the right. So it's negative. So it's negative. Okay. Again, these are just some examples. I do have some more notes to cover. Okay, this last bit, this is the mathematical portion that I was telling you guys about. This is what's called the slope formula. So the slope formula is, again, we have m, our slope, equaling rise over run, but it's going to be whatever our points are. So let's say we have 2 points. Point 1 is x1 comma y1, and then point 2 is x2 comma y2. Okay, so I'm going to take y2, and it doesn't really matter which point you choose as point 1 or 2. As long as you stay consistent, you don't pick this y and then this x to be in the same point. That wouldn't work out. So I'm going to take this y, subtract that, booyah, and then this x, subtract that, booyah. All right, so here's an example. So in this case, we don't need to graph it. We're actually not going to graph it. We're just going to find the slope through these points. Now, I've chosen this point here to be point 1 and this point to be point 2. Again, it's always x comma y, x comma y. So what we do is we take our y2 and we're going to subtract y1. So 4 minus 6 is going to give us -2. And then x2 minus x1, 3 minus 1 is +2. Now we got to simplify this. -2 divided by +2 is -1. So our slope is -1. Okay. Those are your notes for today, guys. I will be seeing you all tomorrow morning. So I'm excited to see you then and catch up. If you have questions, then let's talk about it then. Otherwise, I love you. Bye.